Hi, my name is Nicole. Today I'm going to be looking at a coefficient of variation for a company. Trump Healthcare Inc. has laid out what it believes to be the probability of distribution for its stock. It has given us the likelihood of either a boom, a recession, or just a regular state of the economy, and it has given what it believes the stock's value in each of these circumstances. Using the probabilities of each state of the economy and the value of the stock in each situation, I'll be able to calculate what the coefficient of variation for the company's stock is. I'll be doing this today using Excel. In order to calculate the coefficient of variation, I will need to calculate the expected return and the standard deviation. If you remember, the coefficient of variation is equal to the standard deviation over the expected return of the stock. So I'm first going to calculate the expected return. The expected return is equal to the probability of each situation multiplied by the stock's rate of return in that condition. So in other words, the probability of a boom multiplied by the stock's return in the boom plus the probability of a normal economy multiplied by the stock's expected return in that economy, and then again the same thing for the recession. If I'm using the numbers that I was provided with, so the probability of each situation and the stock's expected return, I can just plug those values into the formula. So the probability of a boom is 0.45 here. So 0.45 multiplied by the stock's expected return, which is 25% in the boom, plus the normal economy, the probability of that happening is 0.5, multiplied by the stock's return in that economy of 15%, plus the recession, which has a likelihood of 0.05 multiplied by 5%. So that gives me an expected return of 19% on the stock. Again, that's the expected return. In order to calculate the standard deviation, I first need to calculate the variance. The variance takes a little longer to calculate, so the general formula is the probability of return 1 multiplied, so this is where it gets tricky, it's multiplied by the stock's expected return in that situation. So if we're looking at the boom, for example, we take the probability of a boom happening multiplied by the stock's return in that boom, and then we subtract the overall expected return, which we calculated above here, and then we square that. And then we add that for the probability of return 2 and so on. This is the general formula for everything that we're going to add together. So to do that as an example, we'll take the probability of return 1, so the probability of a boom happening, 0.45, multiplied by the stock's return in that boom, so 25%, minus the overall expected return of 19% squared, plus the probability of a normal economy, 0.5, multiplied by the stock's return in that economy is 15%, minus the overall expected return of 19% squared, plus the recession has a likelihood of 0.05 times the stock's expected return in the recession of 5% minus the overall expected return of 19% squared. So if I do all that, I get a variance of 0.34%. The standard deviation is equal to the square root of the variance. So I'm going to take the square root of 0.0034 or 0.34%. That gives me a standard deviation of 5.83%. So I've got the standard deviation here, 5.83%, the expected return of 19%. So I can calculate the coefficient of variation is the 5.83% over 19% equals 0.3069. So that is my coefficient of variation. I'm now going to solve this problem using Excel. I'm now going to solve this problem using Excel. I've laid out the formulas that I'm going to be using. So again, to calculate the coefficient of variation, I need to take the standard deviation and divide it by the expected return. So to calculate the standard deviation, I need to first find the expected return. I'm going to put in the information that was given to me. So I know that the probability of a boom happening is 0.45. And the expected return of the stock in a boom is 25%. The probability of having a normal economy is 0.5 or 50%, and the stock's expected return in this situation is 15%. The likelihood of a recession is 5%, and the stock's expected return in this situation is 5%. So, in order to calculate the expected value of return, what I'm going to do is I need to take the probability of each situation and multiply it by the expected return. So instead of taking the probability, multiplying it by the expected return for a boom, and then adding that to the probability of normal economy multiplied by the expected return, and so on, I can just take the sum product of these two arrays. So I will put in the array 1, which is the probabilities, and then the second array is the expected return. That gives me an expected value of 19%. Now I need to calculate the variance. This is the long one. So the variance is going to be the probability of return 1, so the probability of a boom, multiplied by the expected return in the boom minus the overall expected return that I calculated. And I'm going to square that. So I've got my boom covered here, so I'm going to add the normal economy, so the probability of a normal economy, multiplied by the expected return in that normal economy, minus the overall expected return that I calculated here, squared, plus the recession, so the probability of a recession, multiplied by the expected return in the recession, minus the overall expected return that I calculated, to the power of 2. So my overall variance is 0.0034. In order to calculate the standard deviation, I just need to take the square root of that variance. So the square root function is SQRT, and then just put in the number here, and it gives me the standard deviation of 5.83%. Now that I have the standard deviation, I can take that and use it to calculate the coefficient of variation. So the coefficient of variation, again, is the standard deviation here, 5.83%, divided by the expected value of the return. So I get a coefficient of variation of 0.3069.